Find a polynomial p of degree 4 with zeros I, negative I, 2, and negative 2, and with p of 3 equals 25. You'll notice here we've got some zeros that are not real. We have I and negative I, okay, the square roots of negative 1. And that doesn't really change how we would approach this type of problem. Okay, if we know the zeros of a polynomial, that means we know the factors. Since I is a 0, we have x minus I as a factor. Since negative I is a 0, we have x plus I as a factor. 2 gives us x minus 2, and negative 2 gives us x plus 2. Okay. So this is a factored form of a polynomial with these zeros. The other possibility that could change this is just this p of 3 equals 25, and that all comes down to the leading coefficient. I'll just put an a there. Okay. So now what we need to do is kind of multiply this out, and this doesn't ask us to find an expanded form, so I'm actually not that worried about it, but I would like to write it without the i's in there. So I'm just going to multiply these two. So I've got, if I just distribute all this, x times x is x squared, okay, and then x times I is ix, and then we have a negative I times x, and then we have a negative I squared. And negative I squared, well, I squared is negative 1, and so a negative I squared is positive 1. Okay. And you'll notice, of course, that these cancel out here, so this just becomes x squared plus 1. So we've got that x squared plus 1, and we've got the x minus 2 and the x plus 2. So this is a factored form of a polynomial into linear and irreducible quadratics, okay? And we do have that leading coefficient that we don't know yet. That's my p of x. And I'm not worried about expanding the rest of this. I'm fine with it in this way, this form. If this had asked me for it in expanded or standard form, then I could multiply it out. But I'm not really worried about that. I do want to find this leading coefficient, though. So to do that, I'm going to go ahead and plug in this information right here. So p of 3 equals 25. So if I go ahead and plug that in, I've got p of 3, okay, is 25. But p of 3 is this expression if I plug 3 into x. So I have a times 3 squared plus 1 times 3 minus 2 times 3 plus 2. And then I can simplify. So I've got 25 equals a times 10 times 1 times 5. And that's 50 times a. 25 equals 50 times a. So now I can divide by 50 and get a equals 1/2. Now if I take that and plug it back in up here, then I've got my p of x with my leading coefficient of 1/2. And then those